All right, everybody. Welcome to week 8 of the Academy sessions. Um, we've covered a lot of stuff. I think the last two we kind of showed the higher level of more complex, assembly of graphs into this sort of project ELIZA that we're doing. But I think I covered a few things in very, very brief detail that we probably want to go over a little more because they'll be very helpful. And these are more like conceptual things. Some very practical things, but also some conceptual things that we should review again. We had talked about the OODA loop, OODA, which is observe, orient, decide, act, and this is really used very commonly in the military, in business, and it was a sort of idea that if you follow an algorithm for decision making, you can. There's better ways to do it than just randomly like thinking and reacting. And if let's say we're in like the middle of a battle or something, and this all came from John Boyd, who was a military guy, and if you were in the middle of a battle, your ability to win that battle might actually be decided by how fast you can iterate this loop, right? How can you not just execute once, like observe and then start doing stuff, but actually treat this like a loop where you could start by figuring out everything you need, all the context, the information about everyone involved in the world, orient around kind of, the greater context of what you're in, and, in the traditional thing that might be like, in the traditional kind of loop that might be like cultural traditions. But in our case, that might be like additional context, knowledge, memory, pulling in anything you need, then make a decision on that, which is basically like, how do I act, right? What do I need to do and how do I do it? Kind of reasoning through that, and then actually acting and running, doing something. And so if you're like a virtual assistant, this could be, listen to your boss, collect all the information that you need on what they're trying to do, reason about how to do it, and figure out what is important, what's not important, and then actually execute. And you might execute one step and then go back, get more, maybe go get some feedback from your boss. Use that feedback to kind of change your opinions and hypotheses, reason about what you're going to do next, and then do it again. And eventually this becomes so second nature that you're just doing this constantly all the time. And we are kind of constantly doing this all the time, even if we're not conscious of it, when we're kind of doing hard decision making. So we want to kind of bring this is a really useful, we've talked about this before, so I'm kind of repeating myself, but this is like a really useful sort of loop to starting to understand how we could make like a cognitive loop for an agent. And we've kind of built an abstraction that mirrors this idea, what we call the task. And we didn't invent the task. Task has been around for a while. There's a bunch of different, AI stuff on doing tasks, but it's an abstraction that we like, so we're kind of using it and keeping it. One other part of this we should probably start with is we're going to start with putting graphs inside of graphs and talking about the subspell node, because that's really important also to executing tasks, right? If I just have one large hard-coded graph, like I have this really large this is not even that big anymore. There's a lot going on here, but it's actually the ability to this is all hard-coded up here, right? These are definitely very specific subspells that I have, and they do something. But where the magic is really going to come through in Magick is kind of being able to call any subspell, encapsulate a bunch of logic in it, and then do something with that. So in the chat handler here, this is all pretty deterministic, right? Like you definitely get input, and it goes into one of our debugs if it's got a slash command, or it goes down, otherwise it gets processed through all this stuff. God, we really need to fix the scrolling, huh? So it comes down, kind of through this pipeline, and if it is, depending on what kind of intent we recognize, we might call a different spell. And so we have this spell by name node. So usually we sort of specifically call a spell, like I have this module get analysis mode or find interest, and each of these is a subspell that contains a bunch of other nodes, and I can open that up and you can see all the nodes that are like in the find interest subspell, right? But also sometimes we want to dynamically call a subspell, so we have the spell by name node, and that's what that does. And what I mean by dynamic is we don't actually know the name of the subspell at graph time when we make this graph. We're going to try and figure out the name of the subspell that we want to load. And this could be useful for dynamically calling skills, or dynamically calling a different different graph to handle a different kind of input based on what we think the user wants. We can do all kinds of stuff with that. So I'm going to dive into that first, and then we'll talk about tasks, because they're all kind of related. We sort of have three ways to run a subspell. And I'll make a new graph. Let's say test Academy 8. And let's just talk about the three different ways that there are. The first way to start a subspell, which is, putting another spell inside of this one, so that we could use it in different places, encapsulate it. It kind of sits outside of of this graph. The first way we would do that is using the spell node. And what the spell node does is it lets us treat another spell like a node, right? Cool. So I have a graph. I have this graph called public var test, whatever, and it's got a couple of variables in it. You can see this one is called test string, and it's public. And you can see this one is called test text, and it's public. So I've got this very basic public var test spell. It doesn't do anything. It just has a couple of public variables, and it echoes. If I go back to my Academy 8, I'm gonna add that as this subspell, and I can type that in. And you can see now that I have this public var test subspell. And you'll see that over here on the left, it has a test text and it has a test string. And those are corresponding to the public variables here, test text and text string. So the advantage of this is that it lets us customize certain variables going in to the subspell, and we can deterministically decide what those values are. What we're going to be adding here really soon is also the ability to add these by input. So when you select the drop down, you'll be able to drive inputs into this, and they don't have to be manually typed in, and that'll make it fully dynamic, right? You have to select a specific spell you want to run, but the actual inputs to it could be dynamic, which means that they could change at runtime. You could, be writing a story and pushing content of that story in as the test text here to this spell, and it's changing every time or something like that. Or, the agent name is set by the event here, and it goes into the subspell. Right now, for the ELIZA stuff, we're definitely using these public variables. A good example of that, if I have this add documents here, I can and I have these different. I used to have add intent, add interest, add skill. Instead, what I did was I made a single add document node. This is a subspell, and I pass in the add skill and the document type of skill. Right, very simple. And for this one, it's add intent and intent. So that way, instead of having three different graphs, which basically do the same thing, I have a single graph, and it has public variables which let me customize how that graph is used and how you interact with it. So this, the net result of this is, instead of having 5 different graphs which I have to maintain and change and all that, I have one graph, I can open it up, and it handles any kind of input that does this document adding. So back here you can see I have this other subspell, and if I want to run it, I'll delete the echo node, and I will just pass the entire output here into it. So you don't have to pass any specific, you can pass any input you want. We could pass the input event that came in from my playtest here, or Discord or whatever. I could also just pass in the content. The important thing is that you know that if your subspell takes just the string content, that here it would be the same, right? You wouldn't have this destructure here, because you wouldn't be destructuring an event. You would just be getting the content. So you'd probably even delete that, and you'd just plug this in. That's kind of it, right? Imagine that doesn't exist. But a lot of times I like to pass in the entire event, and that way I have all of the event data to do stuff with inside of the spell. And the other thing that I can do is I can pass additional data onto the event. Like I can add stuff to the event if I need to get it in, and the event is different. I can show you that in a second. But concretely, I don't need this. I'm just going to pass the event directly into the subspell. And now the subspell is going to receive input as though it was directly from this kind of root graph, pass it through, and respond with output, which will come out of this output. And ideally, if I say, hey, what's up? Well, it ran, but I'm not seeing any output. So let's make sure that, well, that would be why. Something happened here. Let's think we need an event destructure. Make sure this is all wired up and saved. And then I'll come back here. Hey, what's up? And you can see that I get a response of, hey, what's up, right? So where's that coming from? Well, it's coming in the input. It's going into the spell, which is over here. It's just calling, pulling out the content, echoing it back to the output, returning the output back from the subspell out here to the output, right? Now, let's say I just want to log what's happening with this. This is a test string, right? I want this to be the log. No matter what I type in, I want this to come out. Yeah, sure. I come back into my public var test, and instead of echoing the content, I'm going to echo the test string. This is a public variable. You can see error not set from outer module. Let's say that. So if this test string is not, if I just call it here, hey, what's up? Let's just say that's called from inner module, right? That's more descriptive. So I say hello. You can see it says called from inner module. So it's actually pulling the value that was set inside of the graph. If I call it from the Academy 8 over here, called from Academy 8 spell, hello, you can see that it's overriding that inner variable with this outer variable of test string. Sorry, there's a loud blender here. We'll give it 1 second. Sip of my coffee. So this is one of the ways that we can embed a lot of complexity into a large graph, and then instead of having to have this massive amount of all these nodes all over, we can break it down into commonly used nodes. And I already did this quite a lot. One common thing that we need is we always need to have an embedding, right? Let's see. Let me open up the find interest. We always need to make sure that we have an embedding when we're going to do something related to embeddings. But when I type into the playtest, it doesn't by default create an embedding because it costs money, and you probably want to specifically do that. You don't want an embedding for every single input that comes in necessarily. You want some control over that. So what I did was I created a node here called check embedding, and this is a subspell. And what it does is if it doesn't have an embedding, it creates one. This find interest subgraph uses an embedding to do its interest search through the documents. If it doesn't have an embedding, it's just not going to work at all. So to make it easier to debug and troubleshoot, I've added this check embedding here inside of the graph. So even if we pass in the embedding from this graph out here somewhere, like we generated over here and we pass it through, we still should check it just in case, and then we can actually go into our, even if I'm in this interest graph, I can, it'll have an embedding no matter what. So this check embedding says, if I don't have an embedding on the input event, add one. And you can go in there and you can see there's a bunch of complexity. So instead of having these 7 nodes in every single graph I make to check the embedding, I can just grab this, make it a module, and then have a pass-through flow where the input comes in, gets transformed, and then comes back out, right? So so anything that needs an embedding should be coming from this output right here. And then that gets passed into all of these other find document name, document related, these other nodes and stuff that also need an embedding. Now, I have the same problem inside of here, like this find document name, where I also might need an embedding, right? What happens if this doesn't have an embedding? This is also going to fail because it's definitely trying to, get a value of an embedding from this document. So this is going to fail if I type in here, hey, what's up, right? It's just going to error because there is no embedding. So how do I fix that? Well, I can add a spell, and I will add my check embedding spell here, and I will pass in those values, and then I can pass it out like that. Make sure that's gone. And lastly, I have this kind of event that gets passed out. Make sure that it's get analysis mode. Yeah, that seems okay. Maybe I'll, instead of taking the event from here, now I can take it from the embedding where it already has one, right? So instead of the output getting passed, or sorry, this respond node getting past this. Actually, that's fine. Never mind. This looks good to me. So what I did was I added the check embedding node in place, and now the input will go to the check embedding node, which will add an embedding if it doesn't have one. And ideally, hey, what's up? Well, I've got an error somewhere else, but that's a totally fine error for me. It got through the get documents. Probably the reason is because it couldn't find documents of that type. So we'll say, hey, what's up? Oh, it worked. Hey, what's up? You can see it came back with none. The value was none because it found a document for intent of none. That was the intent it found. So it was not working because it didn't have an embedding. I added a subspell. Instead of having to create all this complexity to create the embedding, I just have this one module I can drop in everywhere. And that's where subspells are really, really useful, is making small pieces of code that you use a lot, modular, and then letting you kind of work with them, and dropping them into different places. So I might have this node in like almost every graph or at least all the document search graphs, because I always need to search, right? I always need to have like an embedding and stuff. And so, another way to use this subspell is, like, you can see this chat handler. It's pretty complex. And if I go to my root Eliza spell, well, I could have 3 inputs, and each one has all of that complexity. There's a chat handler, the loop handler, the task handler. Or I could just say, like, let me just have all of my inputs in one place, and then I can just work on the chat handler. And especially if we were, like, collaborating, I could be working on the chat handler, you could be working on the task handler, and we're not like clashing on, moving nodes around and stuff. So it's a way to encapsulate complexity as well as to encapsulate like different code paths. Even though inside of each of those handlers, there's a lot of the same sub nodes and stuff. We might have this analysis mode or that check embeddings and stuff. You kind of use all over the place inside of graphs. Graphs within graphs within graphs. So the other, I think we've covered, subspells a bit. We've done that stuff before. The main new thing is that the public variables here that let you customize subspells. The next thing that's coming is sockets for subspells, so you can dynamically inject those. But then we have a couple other ways you can call spells. So another really useful way is this spell by name node. And the idea of the spell by name node is we don't know the name of the spell we want to call at runtime. A good example of this would be for intent handling. So you have an intent to respond to the user conversationally. You have an intent to start a task for the user, like do some sort of complex thing. And you have an intent to ignore the user because it actually doesn't seem like it was relevant to your need, right? So how would you decide which one to call in a graph? You could have like a really what you could do is you could have like 10 subspells, right? And you could have like, okay, well this one is gonna be what is it? Like ignore. This one's gonna be knowledge. This one's gonna be task. cool, you've got all these like, and then you can have some sort of crazy branching switch thing here, and you're gonna have this really complex graph that's handling like not just one. Basically, what you're doing is you're making it not dynamic. You're hard coding kind of these graphs together and saying, well, let's say I add like a switch, right? And I can have like, ignore, knowledge, and task. So this is the way you might do it, is whatever comes in, right? Let me make like an example of this actually. Just gonna pass this here, and then I might switch on content, and then I could call ignore. If I say ignore here, it will go through and call ignore. Make sure you can see it's calling ignore. If I call knowledge, it will call knowledge, and I'll pass the events in there too. And then if I'm calling task, it'll call task, right? And that's fine, but this gets really, really complex really quickly. Now I've got to choose between all these subspells. And if I wanted to like dynamically add new intents or new skills or things like that, and when I say dynamic, what I mean is that it's not like fixed hard-coded in here specifically. It's something that could be changed later at runtime when the agent's running. That would be really hard, right? I'd have to have this switch, and then I have these, and that's okay. This would be fine. But if I had like 30 different intents or like 30 or 300 skills, it would just be totally crazy. There's got to be a better way. So instead of saying, okay, well, I call ignore, or I call knowledge, which would call this one or whatever, I'm not gonna use the switch. I'm actually gonna get the spell by name, right? And so instead of having any subspells, I'm just gonna have this get spell by name. Okay, and it will the spell by name runs the exact same way as the spell, but there's one limitation, which is that you only have the event input. You don't have any public variable access here. Maybe we'll try and figure out how we could do that, but the problem is that since every spell is dynamic and different, there's not really any way to determine what the sockets or the inspector values would be, right? Like, you'd have to have some sort of convention or something. So that's the limitation, but the freedom that you get is that you can call a spell dynamically based on some name. So maybe I will make a text template node, and in there, let's see, I have intent, conversation, greeting, ignore, right? So I will call this Eliza intent, and then spell name. So that way I have a template that you pass it like a basic spell intent, and it will come back with like the full, let's call it spell intent, or let's just call it intent even. And I will add a socket for intent. So now I have this text template. We pass it an intent, and it will give us back a template. Oh, come on. This is a weird bug. I'm probably going to need the team to figure this one out. I can't see the save button on my text editor. It's weird. Okay, well, we'll take a look at that. Hopefully, Liza intent, save. No, it's just not gonna work. All right, I'll do it a different way then, since I gotta fix the save button. We're going to have a combined text node, and we will say prefix and input. And the prefix will be a string variable, which will be Eliza intent, like that. And then the input will be whatever our content is. So now we have this like dynamic spell name, right? It's like Eliza intent, whatever task or conversation. And if you look at my naming here, I have Eliza, intent, conversation, greeting, ignore. That's kind of the... So I'm trying to create this spell name right here, right? But I don't really want to have to add... I just want this to be like dynamic, like, I mean, just appended to the front. It only looks for intents. You can do this however you want. This is just like a convention I'm using. Cool. So we will do combine text. And we're taking in the content and appending it. And then we're going to pass that output string, which should be like Eliza, intent, conversation or something, to the spell by name. And we're going to take the input event and we're going to pass it in. And that's the data that gets passed into the spell, is whatever the event data is. If you wanted to add some event data, like you don't, well, you're going to have to make sure that you check, validate, like get it out of the spell from the event and make sure that it actually exists, because you might accidentally not like pass some event data. But a way that you could pass additional data in would be to use the merge objects. I think merge objects would be good. What merge objects does is it takes an object, like the event object, and then we're going to add in, good question, like what should we add? We could just add a value, right? We could add like test value, and then I could make another, string variable, that's what I want. String variable. Test value, this is a test value. And I can pass that in, right? Merge the event with that test value. Get this going like that. And then last part, I have to cast this event. Sometimes you get something like an object which is green, and an event which is also an object but it's blue. I think we talked about this last time. If you want to make sure that the green goes into the blue, you can see it just won't work. It won't let me do it. But I have this really handy cast node, and if I cast to an event like this, I can pass this object into the gray any input, and then pass the output out of the event. Theoretically, I have to refresh. And then I can trigger. And so what I've done is I've taken the name of the spell, added some data to the event that goes in so that I can handle some custom data, and now I'm calling the spell. Right? Now, what spell am I calling? It's actually going to depend on what I type in. So if I type in conversation, let me make sure that conversation undefined, Eliza, intent not found. Cool. Okay, that's good. We're getting somewhere. I think that's because our input and our prefix are flipped. Oh, that's interesting. Might need some way to sort those. Let's try that again. Let's just see if we're getting an undefined. Input. Oh, no, prefix does need to be first. I don't know. I don't like this way of doing it. Let's just get rid of that bit, and we'll pass in the name directly. Eliza, intent, conversation. Right. That's the one I want to call. And that would help if I put the trigger on. Cool. Eliza, intent, conversation is called. It passes through. It calls the spell. It returns an output. Now, I don't know. It should do something here. It's, maybe respond, but it does seem to be working fine though. So yeah, what did I do? I took in an input. We merged in some random data for test value into that object. We passed it into the spell by name. We call it, and then an output comes out. Now, let's say greeting. That seemed to work, but I'm not seeing a response. That might just be because of the way the response handler is. It's just not calling it. should be giving me an output. And I can go look at that intent. I call it the greeting intent, right? And you can see it has an output. Do I need to override the output? Maybe. Let's see, let's go back to our... There we go. Okay, I needed to pass a couple little bugs in the thing. I just needed to make sure that the event that we passed in here into this input was also getting passed back to the output so that it can respond with that output event. And now you can see that I call it greeting and it's saying, hello, how can I help you today? And I could call knowledge. It's actually going to have the same problem with all the graphs. I have to go update them. But let me just make sure. Let me just open up conversation really quick. Let's do the same thing. Let's make sure that the input event is passed to the output object. This is something we're trying to clean up, but because this is a subgraph and it's getting the input event from somewhere else, it has its own input event data, right? Like, because it's its own subgraph. But we need to pass it from the root graph that was on top of it. So that's why we have to pass we have this event override, because it's actually overriding this own like subgraph run to take in the event data of the parent run, which allows it to respond with output. And I think we're cleaning this up a little bit, so you won't need to do this, but that's just kind of like, if you're not getting output from the subspell, you might need to be passing the input event into the output, right? Like this, right? And that's what this event override does. You can pretty much ignore this if you have a single spell kind of thing, but if you have a complex embedded graphs within graphs thing like we do, you need to inject the event into this event override in the output. Definitely something we could probably simplify though. Cool. So now when I call, close a few of these, got too many open. Call a conversation. So if I call greeting, you can see it runs the greeting, and if I call conversation, hopefully it works. Refresh. There we go. Doesn't want to go. It seems like it is going, it's just really slow. There we go. It just came up with a really, really long conversation response. Great. Cool. So greetings are really short. Conversation has a longer prompt and generates a longer response. So it takes a little longer. And that's why we can even split things up, because the greeting is cheaper. We can even have the greeting just be like a pre-canned greeting, right? And we don't have to use the language model at all. So this is a way that we could say, okay, we have conversation, we have greetings, we have tasks. Some stuff was just like deep knowledge of Magick that we want to recall. And those are usually like kind of discrete different spells. We could have different prompts. And that gives us a little bit of specificity, so we don't need like one general prompt to rule everything. We can use this kind of way to set up different intent handling like this. So to recap, we have the spell node, which is in the IO of context menu. Oops, that was weird. And you can select a module from here. We have the spell by name, which is the exact same, but you pass in the spell name. And the difference is that you don't have public variables because you don't know what spell you're going to call ahead of time. So we don't even know what public variables would be exposed. But otherwise, they're very similar. That's going to pass the output back here. And we have another way to call a spell. And this kind of gets us into tasks. So let's go down to, let's see, I got start here. We have a bunch of stuff in tasks, but actually this one is in experimental right now, and this is skill. And so a skill is also a way to run a subspell, and it takes very similar inputs. It takes a spell name, but the difference is that the skill takes in a content input, and it takes in a task input. The content input that it takes is the like kind of the step objective or the reasoning for executing this part of the, like, for running a skill. You could actually pass anything into the content of the skill, but that's kind of what it's going to use to try and execute the skill. And so the way we think of skills is, it's things you know how to do. If I say, can you play a song on the guitar, and you know how to do that, you pick up a guitar and you start playing the guitar, right? You could break that down. You could say, okay, well, actually, I need to like put my left hand on the C chord, and that could be a skill. I need to strum this pattern, and that could be a skill. Because each of those skills is actually wrapped up inside of a task. And so the task is you're playing guitar, but you have all of this kind of general skill of being able to play the guitar, which is actually a bunch of sub skills of like, the individual parts of how you might play the guitar. So skills can have different granularity. I'm going to get into skills, but I think we need to contextualize a skill inside of a task. And so we'll talk about tasks in a second. But the thing to know is that the skill is the same as the spell by name node. They work the same way, right? They're calling something. The main difference is that the skill takes in the content input, which is some information that it needs to perform a skill, usually the output of the reasoning step of a language model in our little loop. And it also takes in the task. So it doesn't take in an event, it takes in a task, which is another type of object. It's very similar to events. But it's going to contain information about the running task that the skill is involved in. So skills are always sort of part of your task loop, right? This is very essential to our idea of tasks. So we're going to talk about tasks. This is kind of where we started. We started with the OODA loop. Let's say we have a task which is go find the first, go search the first 100 pages on Google and get all of the information about elephants, or do a Google search about elephants. Go through each of the first 100 pages of Google, collect all of the information that's relevant to elephants, and then deduplicate, delete anything that's duplicated in that information, and then write an essay. That would be like a nice task, is like basically using the internet, write an essay about elephants, right? And so you can imagine, well, what are the skills that I would need to do that? I should read about elephants a little bit, just to even know like what kinds of things to look for, right? I might search the web generally about elephants and just get a summary of elephants. Then I might plan, or maybe I'll actually start with even the planning loop. Like, okay, well, the planning would be, I should probably go get a summary of elephants and then go search for the elephants, right? And once I've kind of done that, I can get all of my input information, and then I can start to reason through the different steps of doing that. I definitely need to search the web. I need to, for each link that I get from that web search, I need to open it and extract the web contents. Then I need to take all of that extraction and compare if the contents are similar to each other. And if they are, I should probably deduplicate that. And then I can take all of that remainder and I can summarize it. So that's a really complex ability or task. Like, that's like the forefront of AGI right now. That's the kind of thing we're working toward. So like how would we do that? Well, all right, let's talk about it. Going back to my notes here, we covered kind of subspells. We covered skill nodes a little bit, but we're going to come back to that. Let's talk about, we talked about tools and skills a little bit the last time, but I think they become more relevant now. So the tool abstraction is basically like, we kind of get the tools for free in Magick. And a tool would be like search Google, right? The Google search is a tool. You're providing an input, like you have a query, and you get an output, summary and links, right? But how do you determine what a good query is? How do you validate that the query is anything? Like maybe you want to check if there was a query, and if there isn't a good query, you could respond to the user, hey, actually that's a bad query, can you try again? How do you, you get a summary out of this, but then how do you like take each of the links and go one by one and pull the information out of those? There's a whole lot more going on to a Google search than just search Google, or like calculate math or some of the other popular kind of tools. There's a whole skill around searching Google. And if you're good at searching Google, you have like all these little sub things in your brain, like little tricks and filters, and that you just like have to jump 1/3 down the page to get over the ads and blah 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 blah. And you can imagine all kinds of different tools, a calculator, a notepad, And those are cool, but they don't really cover a lot of the complexity of how you would actually use a tool. In something like AutoGPT and a lot of the chain of thought, LangChain kind of stuff, it's all about these tool abstractions and then having a general reasoning loop that reasons over how to use a tool. For us, what we really care more about is reasoning about what skills to use, and those skills encapsulate various tools. So let me open a skill. I don't have a lot of good skills on here yet. Let's do like plan, the planning skill. A lot of skills are just gonna be specialized prompts. Planning is a good example where we have a prompt that tells our agent to write a plan. We don't have to go out to Google or do any external API call stuff. It's just internal, and a lot of the different skills will be either like that or just very simple, like changing state, like completing the task. And so you can see that this planning task has it's a whole pipeline. There's a whole thing going on here, and this is like one of the simplest tasks, right? But we've got to get the input. We want to kind of build a template out of the inputs that we got, which is this template here, and then that template is the prompt that we pass into our generator for our plan, and then we'll respond with our plan. And so for searching the web, for planning, for anything, we're probably going to have like some sort of pipeline here that we want to massage data, validate it, add stuff if it's missing, reformat it. Maybe part of the search Google could be like reformat the user's input as a question or something like that, right? So, sorry, there's a loud blender. Coming back here, we have this idea of a tool, and we have this idea of a skill. I think that if I were to make a skill called, I wish I had the Search Google skill running for you right now. But basically imagine that there is a skill for searching Google, which is also called Search Google. But it would be a lot, it'd be a whole flow of nodes handling stuff. And then we also have inside of that the basic node for Search Google, which would be like the tool. And if you look at LangChain, chain of thought, a lot of the modern papers, I was just looking at a great paper, which I'll post in the Alpha Chat in a bit. Then they talk about the tool abstraction a lot. But if you look at something like Amazon Echo, like Alexa, they talk about skills a lot. And so the way that they, like, what they're trying to do is say, okay, the user has an intent. They want to do something. Let's try and match that to the right skill to execute that. And so with Magick, we can do either one. We can have a lot of tool nodes like this, and you could just kind of build a loop where you have a general intelligent reasoning loop, and then you kind of pull tools in as needed. But this skill and the kind of the skill abstraction makes a lot more sense for how we're doing this. It also lets us do things like call skills dynamically, as we saw with that skill node. This takes a spell name, and that can be dynamically determined. So we could have an intent recognizer that says, oh, you want to have you want to respond with, you're trying to check your email. You want me to check if there's any new emails and respond to them on your behalf. Like that might be a skill or a task we have. Then check email might be a skill, right? Assuming that you had that all set up with connectors and stuff. So let's look at the, zooming back. I feel like I'm jumping around a little bit. I apologize for that. But I'm trying to sort of map these things together so that we can kind of understand what a task is. So if I open my root graph of Eliza, you can see that I have a chat handler, which takes in the input from Discord, and I have a task handler, which takes in the input from the task input. So what is task input? So when you create a task, it gets added on to the task loop. And the task loop, every agent has one, but it's only enabled if you go down and you enable the agent task runner in your agent. So you can enable that. By default, your agent is not going to run tasks. It can create a task, and you could even tell it to step through the task, or you could run the whole task loop inside of a complex node, like other thing, whatever. But if you want your agent to be running tasks while you add them automatically, you have to enable the agent task runner in your agent. So we have this task input. Well, I guess first off we should talk about how do we create a task. One of the intents that we can call dynamically is the task intent. And so when I say, hey Eliza, can you check my email? That doesn't sound like a greeting. It doesn't really sound like a conversation. It sounds like I am asking the agent to do something. And we have some intent recognition, which matches intent documents to the most similar document is going to be the one that maps to whatever spell we want to call. And so let's say that we have a document for email and it maps to the task intent. Then we're going to run this task intent spell on the user's input. And the way it works is we get the most recent conversation. We need some of the conversation to sort of determine the context for what the task they're trying to get us to do is. We take a template, which has some example task, examples of tasks, and what we expect the output to be. And then we're going, like this template generates an objective. So we use this generate task here. Generate text. This generates the objective for the task. This is just a chat node, right? And that output of the language model is gonna go in as the objective to this create task node. So this is the important one right here, right? Create task. And if I go to my task menu, you can see I have a create task node here. And this task has a type. You can have different types of tasks if you want, but they all run, and that's really just for tracking. You could have agent, blah, I don't know, whatever you want. We just want to be able to later be able to sort tasks by type sometimes. Don't worry too much about the type. The main important thing is that you pass in an objective. When you've created a task, it's going to add it to the task queue. So you can see here, once I've created the task, the rest of this is like just responding to the user and letting them know that it was created. It just says I've started a new task with the objective. Cool. But the actual task is created at this point, and it's done. It's added to the task queue. Now if I go in here and I say, can you check my email? It's going to make a call, hopefully. It might be a really long response, yeah. I gotta, But you can see I'm a large language model, I'm starting a task. I am not able to access your email account. Okay, well, we gotta work on that, right? Obviously, we don't have email handling in quite yet. But imagine that, well, it did create an objective, and it did create a task. So now the task is created, and I can see the task here. You can see I'm a large language model, some garbage. We gotta fix the prompt, but but it did create a task with an objective. And I could say, check the user's email and respond with any new ones. I can actually change the task here dynamically, because I can see it, I can change the objective, and you can see that it has a list of steps, but the steps are empty. So one of the things we're going to be working on quite a lot over the next couple of weeks is being able to debug tasks. Stop tasks, pause them, see what they're doing with the agent live, get full feedback of every step of the task reported to you so that you can see what's going on and you can debug it. I predict that the hardest problem to solve with agents will be really good development and troubleshooting flow over these like complex running systems. Because it's not like you could just make a test for it. You probably could, but a lot of times even if you made a test for it, you might get some really strange behavior somewhere in the middle of it, like running or reasoning or figuring stuff out. Especially if you're adding a lot of like augmentation with knowledge and document stuff and all these complex things, you get some. It just really becomes really hard, in the fifth step of a task that was dynamically generated by language models. If it doesn't do something right and you get an error, you're gonna have to go find that error, but you're gonna have to dig through like everything the agent is doing and thinking to find that error and then debug it. It's not great. So a lot of what we're working on with Magick is making it easier to debug live running agents and tasks, and we're really changing the paradigm here. This is something that Parsball especially is working on, to make it so that you're accessing a live running agent and seeing what's going on inside of them. It'll be very Westworld. It'll be awesome. But that's especially important when you have a task, because a task isn't just, oh, let me run the chat handler, hey, what's up, blah, 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 get a response. The task is like, it's going to be running, it could be running for 10 minutes, it could be running for an hour. You could have tasks that go all day. There's no reason why a task has to end, but it is nice maybe to encapsulate a task and make sure that it does have a completion, because it will eventually start forgetting what the last steps it was doing were and stuff like that. Cool. Let me get back to. Let's see. We open up the task handler. Okay, cool. So we know we want to create a task, and we added it. We created a task in this intent for the task intent, and we added it to the task queue, right? Now we have a task handler, and this task handler gets called every frame of the task run. So if there is an active task, sorry, we'll go back here. You can see the status of this task is active. Then the task will run the step. And the steps are, first, take in everything that's happened in the task so far and reason about what the next step is. So this task reasoning subspell here, do I have a, can't find it. Well, we'll figure that out in a second. I might have to re-upload that one. But the task reasoning, generally what it does is it says, what am I about to do? What's the next step that I have to complete, right? I have to, okay, the last step was planning, and I got this plan, and the first step of the plan is that I have to ask the user, I don't know, what their birthday is. So now I'm going to create the reasoning step, ask the user what their birthday is. Then that's going to pass in, ask the user what their birthday is, to the find skill. Find skill subspell. That's weird. It's got some sort of graph finding issue. We'll figure that out. Well, I wish I could show you what these are, what's going inside, but there's a whole lot of nodes inside of these. And in the find skill task, we're going to pull a document whose embedding matches the reasoning as closely as possible. The reasoning would be, I need to get the user's birthday. A likely document that we have is get user input from the user, or get feedback from the user, right? That's a skill that we need to find. And so we might have some stories that relate to that. So if I go into my documents, you can see I have some skill documents. And what I'm doing is I'm searching for the document with the skill type that is the most like what I'm trying to do. One example is the name. This is called plan. And the description is I should write a detailed plan of what I want to do. So if we were to try and, if we're trying to find let's say we have the first reasoning step in our task is, well, I should figure out how to do this. That would probably be pretty similar to this description, which we have an embedding of. And then if we pull this as the most likely document, similar to our reasoning input, we'll get the name plan, and then we can call the plan skill, right? So this name here maps to a skill name, which is Eliza task plan, or a skill plan, I think, Eliza skill plan. And then we have Eliza skill respond, Eliza skill cancel, that cancels the task, Eliza skill complete, that completes the task. So if you reason, well, cool, I did everything I needed to do and I've completed the task successfully, then the last time you call the skill would actually be to complete the task. That would be task completion and canceling are themselves also skills. So inside of my task loop, first I reason about what this step is. I find the relevant skill for this step. I then combine that with Eliza's skill spell name, because the response to the find skill might be plan, right? And so I'm just responding with, it just returns plan. So now I get Eliza skill plan is injected in there. And then I call that skill. And you can see I take the spell name, Eliza skill plan, I take the content that came out of the reasoning loop. You can see the reasoning is getting passed into this content input here. And then I also take the task information. So the input for the task handler, remember it's getting called from the task input here. Task input is a task. The task contains event data, but it doesn't look the same as an event. Remember, if I type in, what's up, that's going to pass a regular input event in to here. But the task data that I pass in is very different, and this will probably just error. Hey. So the way that I've been doing this, well, this is something that we're really going to also fix the next couple of weeks, and this might be a little bit confusing, is let me open back up the task content. I'm going to say check my email for me, and that's the intent. It generates, I'm starting a new task. Sure, I can help you with that. Can you tell me your email address, right? I mean, this is obviously mentioning, but I can go back here and I can see that it gave me a task response. Like this. This is really dirty. I'm going to take that task response, go to my task handler. I'm going to paste that task response in to my data field of my playtest input. This is not how this is going to be in the future, but this is how it is now. And I'm going to convert that to JSON real quick. Fun times. I have to make strings out of the property values. Keys. It's there. This is not something I would like to show in one of these, but it's really helpful to our team for debugging it, so we kind of have to anyway. But this is exactly the kind of thing that we're trying to solve, is not having to do this complex data juggling. So if you're on the team and you're looking at this, take note, we have to solve this as soon as possible. Because we can't debug tasks this way. And this is how I've been doing it. If you were wondering how I was getting through everything, it's doing this. So now I have my whole task, I have events, and now I can go to my task handler and I can say like this. And my JSON was not properly formatted. Oh god. Can I get away without? Yeah. Oh, it's just not gonna. That's great. That's real great. Okay, now it is. Okay, so yeah, some of my spells seem to be missing. I'll have to figure that out. But generally, I take this I have this complex task object that I got from my console, and this is what the task data is. This is what's actually getting passed into the task handler. This is way advanced. This is I should not be showing this, but we just don't have a better way to test tasks internally in here yet. The way you might do it is you might create your agent, create the whole task loop, and then just run it and see what happens and get outputs. But this is the heart of what we have to simplify. But we'll probably show more of that simple process as we get it kind of cleaned up, which is hopefully in the next 2 weeks. But just to give you an idea, we're passing all this task data into here, and then we're passing that through into the skill. And so now the skill has all of the basic data for the the event data that we normally pass, but it's also got this objective, and it's got these lists of steps, which we will fill out. So, to recap, we created a task. The task calls this input task every frame, which then calls the task handler subspell that we've created. The task handler gets called, it runs a reasoning step, it finds the relevant skill to that reasoning, it calls that skill, right, which is a spell. It then gets the response. Basically, we're going to take all of that information. We're going to take the reasoning step, the skill name, the result of the skill, as well as all the task information, and we're going to pass that into the reflection. The reflection is another subspell, which again seems to be not here. Figure that out. The reflection is another subspell, which reasons about how we did on the task and responds with a success or a failure. And if it's successful, you can see that we actually get that object back, and then we get the success of the reflection step as well as what the content of it was. The content would be, I tried this and it worked. And the success would be successful or true. We take all that data and we finish this task step. So the task, remember, this is all considered one step in the task, right? We're doing the OODA loop once. We're reasoning about it, determining what to do, running the skill, and then reflecting on it, finishing the step, and then we're doing it all over again until it's done. So the finished task step takes all that information and it adds a step to the task. So now our task here, instead of being an empty step here, it would actually have a list of steps with all of that data, and then we can access that step data in the next time we run the loop. So the reasoning step here now has access to everything that happened the last frame, right? So on and so forth until the task is completed. And now when the task is completed, we also have everything that happened in that task. We have the why we decided to do it, what we did, how it went, and then how we think it went, in addition to the raw information from that spell. And then we just, we have the complete task. And then we can also use this stuff later for hey, we take all of our successful tasks and we can train a model on it or something, whatever. But this is kind of the essential task loop, right? You have steps, you run the steps until you complete it. One of the spells would be one of the skills, would be complete task, and one of them would be cancel task. And in either case, that's going to still complete through and finish the task step, but if it ends with a complete, then that would be the last run of the steps. And then it would change here to completed. And maybe this one might be canceled, right? And so these won't run. 2 L's? That's right. These won't run because they've been completed or canceled. Only status active tasks will run in the loop over and over. Cool. I think I've gone over a lot. I wish that there's just a few things that are kind of missing to making this experience really nice and easy for troubleshooting. You can definitely create and run tasks now, but I think the crucial thing is to understand how this might fit into your workflow, the concepts, and we'll be releasing the whole Eliza, the latest version. Obviously I have to fix a couple of these and re-upload these spells, but we'll be releasing the whole thing and you can look at it, modify it, and 2, we'll be making it much easier to debug and troubleshoot the task and see all of that. We'll actually have a new thing coming in where you'll be able to see the entire logs of your agent running, and see every step of the task, and that will probably help a lot with debugging. So this is what we're working on, this is what's coming, and this kind of allows us to do a lot of general intelligence, because we can have a list of different skills and stories of how they might start, and as it's planning through its reasoning loop, we can find that skill. We can do a few other things that we'll be getting into, maybe we don't have a story that's that similar. We have 3 skills that it might be one of those 3. Well, then we would know because the similarity of what the intent was really low, and we could decide from there to maybe have a language model decide between top 3 skills instead of just picking the top one. That's the kind of stuff we can do in the future. But right now we're just picking the most likely skill and running with it. So, okay, I feel like I've talked a lot. I am going to review the Discord and let's see if anybody has any questions. We can go over that. And just pulling this up on my chat stuff. And cool. Let's see.
What do you mean alone?
Yes. AI debugging is something that we're trying to work on. It's something we'll have here as an agent, as a chat window here. Like, future things we're definitely working on are, can I just tell a chat window, hey, can you solve this problem? Can you create the next node for me? I'm trying to do this. And we'll have AI-assisted spell creation, as well as, and probably even before that, just being able to ask your graph about the graph and get information about the graph is going to be pretty crucial. So that's definitely coming. I accidentally got kicked off my, my phone kicked me off of the stage. Good times. Yeah, can you hear me? I'm definitely not muted. Can you see my screen? I mean, I can hear you. I don't know. Well, I mean, that's kind of the end. I don't have a whole lot more to recap on. I'm not sure. It looks like it's definitely going green here. So I think it's just you, Ryan. It seems to be working for me. Cool. Sorry, I don't know what cut out, but I am recording whatever I just said. I'm sure it was somewhat interesting. But basically we covered, we'll get more into the weeds of what we're doing with tasks. We're all just as a team coming around to working with this. I'm right now the only person who's had yeah, can you hear me? No? Can you not hear me? That's so weird, because it's showing green on my screen. So, hold on. Cool, okay. Sorry, I don't know what happened. I connected on my phone because I was trying to read the chats, and that must have kicked me off. I was going to say that one thing that we are looking at and working on is AI-assisted troubleshooting. Basically, a chat window where you can ask about whatever the current context is. It should give you some information, like if you click on a node, you can ask about it, how to use it, stuff like that. And then eventually node creation, where you could say, hey, can you do this for me, create this? Hey, I'm trying to get the embedding out of this event, and it can maybe solve that by creating new nodes for you. So that's something we're working on in the near future. Obviously, super helpful to have AI assistants when you're building these things. Also, we've got a lot going on. The thing that I think, our team is just getting into using tasks ourselves. I think that we are the first, this is a very new paradigm inside of Magick. It still needs a bit of testing. Definitely needs more on the troubleshooting and debugging side to make it easier. And so this will be where a lot of our focus is making sure that this kind of task-oriented stuff works really well. But I hope this is a good preview of it for you. We'll be dropping all of the ELIZA graphs so you can open it. There is a version, but there should be a new version coming. And we'll probably be releasing those every week. And then, and I think as we get those troubleshooting stuff in there, so we can really actually dig in and see how a task running live, we'll make that a big part of the academy, because I think that's one of the most interesting parts of these kind of dynamic autonomous agents. So cool. You got anything else, Mike? Cool. Any other questions? This one was definitely an explainer. Cool. All right, guys. Thank you. Take care, y'all.